Okay, so this week we're going to look at how to compare means between two different samples within a bigger sample. So let's go ahead and just look at a problem real quickly. So assume a researcher surveyed 227 teenagers who admitted to smoking cigarettes, and one of the research questions was, how old were you the first time you smoked? So we can break down that sample into boys and girls, right? So as you can see there, the N size for males was 107 and for females was 123, right? Those add up to your overall sample size of 227. Now I'm giving you the standard deviation for those two subpopulations. For males, the standard deviation is 1.99, and for girls it's 1.69, okay? And you have a mean of males who said our average age of smoking ended up being 9.87 years. And for females, the average age of first smoking a cigarette was 10.17 years. Okay? Now you're going to need to know the variance later on. So remember, the standard deviation, in order to get the variance, you just square your standard deviation. Okay? So if you take 1.99 and multiply it by itself, you get 3.96, or a variance of 3.96 for males. Okay, likewise for females, you have a standard deviation of 1.69. If you square it, you get a variance of 2.86. So just remember that if I give you this information, the N size, the standard deviation, and the mean for two different samples within a population, you should be able to compare them. Okay? So the question is the male mean different from the female mean to a degree that reaches statistical significance? Okay, and so we're going to make a hypothesis. Now again, you have here results that are already provided for you. Again, you can see the N size, standard deviation, the mean results for each group, and then since you have the standard deviation, you can calculate very easily the variance for each group. But let's assume we went into this research project or if we did go into this without surveying anybody, obviously we would have no results. So you want to go in with what's called the null hypothesis and an alternative hypothesis. What the null hypothesis states is that the male mean is actually equal to the female mean. Okay, and any observed differences that we see between those two means for the different groups are due to chance. Okay, so maybe we could find that the male mean is higher than the female mean, or vice versa. Okay, but the null hypothesis says that if there are any differences that are relatively small, those differences in our sample are due to chance, and there's really no difference between the males and the females. The alternative hypothesis says that the male mean is different from the female mean. Not necessarily bigger or smaller, but different. And any observed differences that we see are big enough that they reach statistical significance, and we'll look at those at the 0.05 and 0.01 thresholds. Those differences are due to another factor in society, okay? Maybe some kind of gender difference. So what we're going to do in order to test for either the null hypothesis or if we get an alternative hypothesis is what's called a t-test. And when we calculate the t-test, if we do find that there are statistical differences to a degree that reach statistical significance, then we reject the null hypothesis and accept the alternative hypothesis. Okay? But if we find there are not statistically significant differences, then we accept the null hypothesis. Now, calculating a t-test is not all that difficult. All you do is you take your sample mean 1 and subtract your sample mean 2 and divide by your standard error. So you take 9.87 years minus 10.17 years and divide by your standard error. Or you could do 10.17 minus 9.87. It doesn't really matter. Okay? But calculating your standard error is the difficult part. So let's go to that now. Okay, so here's your long formula for the standard error. All right, I'm going to zoom in on this. You can take your N1, or your sample size for your first group, which would be 104 minus 1, so that ends up being 103, times variance 1, or the variance for that first group. So you take 103 times 3.96, and then add your sample size N2 minus 1, so that ends up being 122, times the variance for that group, or 2.86. And you divide by something called your degrees of freedom, which I'll get to in a second. So you get that calculation for that whole, and then you get the square root of it, okay? get that whole calculation and you multiply it by the square root of n1 plus n2, or 104 plus 123, divided by n1 times n2, 104 times 123. Get the square root of that, then you multiply those together, and that's your standard error. Okay, so what's your degrees of freedom? Your degrees of freedom is actually the easiest part of this whole equation. You just take your sample size for n1, or 104, plus your sample size of n2 of 123, and then subtract 2 because we have two variables that we're examining. Okay? So it just ends up being your total sample size minus 2. Okay, so here you can see we've actually plugged in the numbers. You have n1 minus 1, which equals 103, times the variance for that sample of 3.96, plus your n2 minus 1, so that's 122, times your variance of 2.86, divided by your degrees of freedom, which is, again, your total sample size minus 2, and then you'll get the square root of that, and you'll multiply it by n1 plus n2, 104 plus 123, divided by n1 times n2, 104 times 123, get the square root of that. You'll multiply those two formulas together, and you'll get your standard error. So if you go through that calculation, on the right-hand side of the standard error formula, you get 1.834, on the left-hand side, and on the right side, you get 0.1332. And then you just multiply those two together, and you'll get your standard error of 0.2443. Now remember, then we need to take that standard error and plug it into the t-test.